If you have red hair, there is something written inside your DNA that makes you one of the rarest people on planet Earth, carrying a genetic variant so specific, so tightly tied to particular ancestral populations, that your hair color alone is almost a genetic signature pointing directly back to where your ancestors actually lived. Red hair is not just unusual, it is genuinely rare, present in less than 2% of the entire human population. And yet, despite being one of the most visually striking traits any human can carry, the gene responsible was only properly identified within the last 30 years. If you are red-haired, or if you've got red-haired children and wondered why their hair looks nothing like anyone else in the family, stay with me, because by the end of this video, you're going to understand exactly why red hair exists at all, why it persists in such small numbers, and why your ancestors were fundamentally different from most of the people they lived alongside. Let's start with the raw numbers because they tell the most important part of this story immediately. Roughly 1 to 2% of the global human population has naturally red hair. That's it. Out of 8 billion people on Earth, only 80 to 160 million naturally have red hair, a number so small that red hair is rarer than blue eyes, rarer than green eyes, rarer than any other visible hair color on the planet. Brown hair dominates overwhelmingly, present in roughly 90% of humanity. Black hair accounts for most of the remaining 10%. Blonde hair, despite being everywhere in media and fashion, only shows up in roughly 2 to 3% of the population. And red hair sits at the absolute bottom of this pyramid, so statistically rare that in many parts of the world, most people will go through their entire lives without ever meeting a naturally red-haired person. If you have red hair, you are statistically one of the most unusual people anyone around you will ever encounter, and your DNA is the reason why. That rarity comes directly from a single gene, the same gene we've covered earlier on this channel when discussing freckles, MC1R, short for melanocortin-1 receptor. But here's the crucial detail that separates red hair from freckles. While freckles can appear in people carrying a wide range of MC1R variants and often appear alongside other pigmentation patterns, true red hair requires a very specific combination of MC1R variants, and the presence of red hair almost always indicates a person is carrying 2 copies of these specific red hair variants, one inherited from each parent. This is why red hair follows what looks like a recessive inheritance pattern, meaning 2 red-haired parents will almost certainly have red-haired children, but 2 brown-haired parents can absolutely produce a red-haired child if both happen to be carrying hidden recessive MC1R variants, a pattern that confuses families constantly and leads to exactly the kind of "where did the red hair come from?" questions that DNA testing eventually answers. Now here's where this story gets genuinely different from almost every other trait covered on this channel. Red hair is not evenly distributed across human populations. It is not a trait showing up at roughly similar rates across Africa, Asia, Europe, and the Americas. Red hair clusters so heavily in specific regions that it's almost a genetic marker for ancestry itself, more reliable in many ways than the broader pigmentation gradients we discussed with freckles and pale eyes. Because red hair requires not just 1 or 2 specific MC1R variants, but a particular combination of variants, a more specific genetic recipe than paler skin or lighter eye color alone. The highest concentrations of red hair on Earth are found in Scotland and Ireland, where certain regional studies have found red hair present in somewhere between 10 to 13% of the population, a number so dramatically higher than the global average that it represents a genuinely different genetic landscape from the rest of the world. Scandinavia shows the next highest frequencies, with red hair present in roughly 2 to 6%, depending on the specific region. The rest of Europe shows rates comparable to or slightly above global average, and across most of Asia, Africa, and the Americas, red hair becomes increasingly rare, dropping toward or below the global 1 to 2% baseline. That geographic clustering is the first major clue pointing toward the real ancestry story behind red hair, because it maps almost perfectly onto the ancient migration routes of populations that geneticists have traced. Through DNA analysis, red hair, far more than freckles, is tied to a specific ancestral lineage, populations that migrated out of the Eurasian steppe into northern and western Europe roughly 4,000 to 6,000 years ago, the same Yamnaya-descended Indo-European-speaking populations we discussed in earlier videos on this channel. These populations carried not just the HERC2 variants, responsible for pale eyes, but also a higher frequency of specific MC1R variants that, when combined correctly, produce red hair. As these populations spread westward into what is now Ireland, Scotland, and Scandinavia, the red hair variants spread with them, reaching their highest concentrations in the populations that settled farthest from the equator in the most northern, lowest sunlight regions of Europe. That geographic clustering is the first major clue pointing toward the real ancestry story behind red hair, because it maps almost perfectly onto the ancient migration routes of populations that geneticists have traced through DNA analysis. Red hair, far more than freckles, is tied to a specific ancestral lineage. Populations that migrated out of the Eurasian steppe into northern and western Europe roughly 4,000 to 6,000 years ago, the same Yamnaya-descended Indo-European-speaking populations we discussed in earlier videos on this channel. These populations carried not just the HERC2 variants responsible for pale eyes, but also a higher frequency of specific MC1R variants that, when combined correctly, produce red hair. As these populations spread westward into what is now Ireland, Scotland, and Scandinavia, the red hair variants spread with them, reaching their highest concentrations in the populations that settled farthest from the equator in the most northern, lowest sunlight regions of Europe, exactly where the survival advantages of lighter pigmentation would have been most pronounced. What makes this story genuinely different from the EDAR sweep we discussed in earlier videos is that red hair never achieved anything close to universal dominance, even in regions where it reached peak frequency. EDAR variants pushed straight hair to above 80% in East Asian populations within a relatively short evolutionary window, a rapid, nearly complete sweep that reshaped an entire continent's hair texture. Red hair, by contrast, reached maybe 15% at its absolute highest in the most favorable regions, and then stayed there, never climbing higher despite thousands of years of continued gene flow and population mixing. This plateau effect tells us something important about the evolutionary dynamics of red hair, that the selective advantages of the trait, while real, are modest and limited compared to something like EDAR, and that the costs of the trait, primarily the fair skin and sun sensitivity that comes packaged together with red hair, become increasingly severe as population frequency climbs higher, eventually balancing out further increases. Stay with me, because understanding exactly why red hair would reach such high frequencies in these specific regions requires stepping back into the same evolutionary logic we've covered multiple times across this channel. Red hair is produced by a specific combination of MC1R variants that signal melanocytes to produce more pheomelanin, that weak reddish-yellow pigment, instead of the dark protective eumelanin. Red-haired people have fair skin, high sun sensitivity, and elevated risk of skin cancer in high UV environments, but also better vitamin D production in low UV environments, the exact same trade-off we discussed with freckles and pale eyes. Populations that migrated into the low sunlight, low UV regions of northern Europe would have benefited from mutations that reduced overall pigmentation, allowing more UV radiation to reach the skin for vitamin D synthesis. That selection pressure would have increased the frequency of any variants reducing pigmentation, including the specific MC1R variants that produce red hair. when present in the right combination. Over thousands of years in the specific population, bottlenecks, and migration patterns that shaped Celtic and Norse populations. Here's the twist that almost nobody realizes, and it's one of the most important details in the entire red hair story. Unlike the EDAR variant responsible for straight hair, which appears to have swept through East Asian populations in a remarkably rapid time frame, creating an almost universal preference for straight hair across East Asia, within just a few thousand years, red hair variants never reached that same level of dominance anywhere on Earth. Even in Scotland and Ireland, where red hair reaches its absolute highest global frequencies, red-haired people remain a minority, never climbing above roughly 15%, even in the most red-hair-dense populations studied. This is partly because the same variants producing red hair also produce the pale skin and sun sensitivity that carry real costs in any high UV environment, limiting how high the frequency can climb before negative selection pressure pushes back against further increases. But it's also partly because red hair reached these high frequencies relatively recently in evolutionary time, within the last few thousand years, not nearly enough time to increase further, even if selection pressures were neutral or weakly favoring, and because the specific population dynamics of Celtic and Norse populations involved continued mixing with other populations, carrying fewer red hair variants, preventing the frequency from ever climbing higher. There's another piece of this story that matters deeply, and it connects directly to why red hair has such a powerful cultural history despite being so statistically rare. Red hair is visually extraordinarily distinctive. In a crowd of 100 people, a red-haired person stands out in a way that almost no other trait can match, simply because the color is so uncommon that most people around them will rarely or never have seen naturally red hair before. That visibility, that absolute unmistakability, has made red hair a cultural lightning rod for thousands of years, attracting attention, fascination, fear, and mythology in ways that brown or blonde hair simply never could, precisely because of how unusual and visually striking it actually is. Medieval and early modern Europe treated red hair with a mixture of fascination and suspicion that often crossed into outright hostility, and understanding exactly why requires looking at the specific cultural and religious contexts where red-haired people lived. Red-haired women were sometimes specifically targeted during witch trials, their distinctive hair treated as physical evidence of witchcraft or demonic influence, a pattern documented across multiple regions and multiple centuries of European history, with some trial records explicitly noting red or reddish hair as a suspicious trait. Some scholars studying witch trial records have found that red-haired women and men were indeed accused at rates somewhat higher than their population frequency would predict, though debate continues about whether this reflects an actual targeting bias or simply reflects the greater visibility and memorability of red-haired accused witches in historical records. What's clear is that red hair carried enough cultural weight, enough association with otherness and difference, that it attracted suspicion and sometimes active persecution in specific historical contexts, particularly in times of social stress and fear. Beyond the witch trial context, red hair also appears in European historical records as being associated with specific negative character traits, historical sources occasionally describing red-haired people using language coded to suggest deceitfulness, treachery, or violence. Some scholars have traced these associations back through medieval sources and even into classical writings, suggesting a remarkably persistent, long-lived cultural bias against red hair in European traditions stretching across many centuries. That bias didn't disappear with the end of witch trials. It transformed, becoming embedded in literature, folklore, and casual cultural attitudes in ways that persisted well into modern times, with red hair occasionally associated with hot temper, unpredictability, or wild nature, in ways that were at least partly rooted in historical prejudice rather than any actual truth about redheads as people. That same visibility that made red hair a target for suspicion also made it a cultural obsession in completely different directions in other eras and regions. Ancient Greek and Roman writers sometimes treated red hair with fascination and exoticism, occasionally associating it with foreign exotic populations or with specific character traits, sometimes positive, sometimes negative, but always marked as distinctive and unusual. During certain periods of European history, red hair was treated as a mark of particular beauty or intensity, celebrated in art and literature as distinctive and striking in ways that were sometimes admiring, sometimes suspicious, sometimes both simultaneously. The pre-Raphaelite art movement of 19th century Britain, for instance, featured red-haired women prominently in their paintings, often using red hair as a visual marker of beauty, complexity, and otherness, a deliberate aesthetic choice reflecting the movement's embrace of non-conventional beauty ideals. Meanwhile, in different time periods and different cultural contexts, red hair was actively discouraged or hidden, with some families reporting that red-haired children were sometimes teased, isolated, or treated as different in ways that clearly drew from deeper cultural biases. The cultural meaning attached to red hair has shifted dramatically across different eras and different societies, but the constant throughout has been that red hair attracts attention and carries meaning precisely because it is so visually distinctive and so statistically unusual compared to other hair colors. Twin studies have confirmed that red hair inheritance follows expected patterns for a recessive trait, with high concordance between identical twins for both red hair presence and shade, and substantially lower concordance between fraternal twins, confirming that specific MC1R variants are doing the heavy lifting in determining who ends up red-haired. The heritability estimates for red hair run well above 90% in most studies, among the highest heritability values for any visible trait we've covered on this channel. A reminder that hair color is one of the most straightforwardly genetic traits humans carry, with environmental factors playing almost no role in determining whether someone will be red-haired or not. What's genuinely fascinating is that red hair, despite its low global frequency, has never been selected out of the human gene pool, despite centuries of cultural pressure, forced assimilation, and in some cases active persecution. Red-haired people have survived witch trials, survived migration into regions where their fair skin and sun sensitivity were genuine liabilities, survived all the historical and cultural forces that theoretically should have suppressed the trait, and they've survived because the MC1R variants producing red hair are genuinely tied to adaptation for low sunlight environments, meaning populations in Northern Europe continue to benefit from carrying them, and because once you have a genetic trait locked into a population at a meaningful frequency, it's genuinely hard to eliminate through anything short of forced sterilization or genocide, neither of which humanity has attempted at scale, specifically targeting red-haired people. The trait has persisted simply because it's adaptively useful in the environments where it reached high frequency, and because suppressing it would require something more drastic than culture and fashion pressure alone could ever accomplish. Ancient DNA research has actually managed to trace specific MC1R variants directly through ancient remains recovered from sites across Europe, and particularly across regions that would become Ireland and Scotland. Work that has dramatically improved our understanding of how red hair genetics spread across populations over time. Researchers have identified specific MC1R variants in Bronze Age skeletons, in Iron Age remains, in Viking-era burials, building a genuine timeline of how red hair-associated genetics shifted in frequency across different ancient populations over thousands of years. Some of the most striking findings involve ancient European hunter-gatherers predating the Yamnaya migrations, whose genomes sometimes carried other pigmentation-related variants, but not the specific MC1R combinations producing true red hair, a reminder that the red hair we see concentrated in northern Europe today represents a relatively recent genetic change in evolutionary time, arriving with specific migrating populations and reaching high frequencies only in the past few thousand years. One particularly important finding involved ancient DNA from Viking-era populations, which showed notably elevated frequencies of red hair-associated MC1R variants, suggesting that red hair may have been even more common in Norse populations than in modern populations, possibly indicating selection against the trait in more recent centuries due to changing environmental and cultural circumstances. That archaeological record is crucial because it lets scientists literally see the spread of red-haired genetics playing out across time, not just inferring it from modern population distributions. Comparing ancient genomes from different regions and different time periods, researchers can build a timeline showing when and where red hair variants increased in frequency, which populations carried them, and how migration events moved these variants across geography. This work is part of a broader revolution in understanding human history through ancient DNA, using the genetic material preserved in bone and teeth to reconstruct the migrations, mixing, and population dynamics that shaped modern genetic patterns. The specific MC1R variants producing red hair have also been extensively studied in molecular detail, with researchers identifying not just which mutations create red hair, but exactly how those mutations change the protein produced by the gene and how that change affects melanocyte behavior. Most red hair producing MC1R variants result in a non-functional or partially non-functional receptor protein, meaning melanocytes in red-haired people are receiving weakened or absent signals to produce dark eumelanin, pushing them toward the default production of pheomelanin instead. Different MC1R variants produce slightly different levels of receptor dysfunction, which is part of why red hair color varies, from pale strawberry blonde to deep auburn to almost brown, but still technically red, depending on exactly which combination of MC1R variants a person carries and how much residual receptor function they retain. Ancient DNA research has actually managed to trace specific MC1R variants directly through ancient remains recovered from sites across Europe and particularly across regions that would become Ireland and Scotland. There's a detail about red hair inheritance that surprises almost every family that encounters it, and it's worth addressing directly because it causes genuine confusion in families year after year. Since true red hair requires 2 copies of red hair-associated MC1R variants, and since these variants are recessive in their expression, it's entirely possible, and actually quite common, for 2 brown-haired parents to have a red-haired child if both parents happen to be carriers, each silently carrying 1 copy of a red hair variant inherited from their own parents and passed down invisibly through their DNA. This has led to genuinely painful family situations throughout history. Cases where a red-haired child born to 2 brown-haired parents triggered suspicion about paternity, when in reality it's nothing more than simple recessive genetics working exactly as it's designed to work. DNA testing has closed the door on a lot of those old suspicions, replacing generations of family conflict with a simple genetic explanation. There's also something worth understanding about the relationship between red hair and other pigmentation traits, because they're all controlled by variations in the same underlying genes, the same MC1R receptor system we've discussed extensively. Red hair is almost always accompanied by fair skin because the MC1R variants producing red hair simultaneously reduce overall eumelanin production across the entire body, making the entire person less pigmented, not just their hair. Red hair is also very frequently accompanied by freckles because freckled skin represents exactly the kind of uneven, clustered pheomelanin production that happens in people carrying red hair MC1R variants. In fact, the overlap between red hair and freckling is so complete that people with natural red hair almost universally carry the exact same MC1R variants we discussed extensively in the freckles video, making red hair essentially an extreme expression of the same genetic story that produces scattered freckles in other people. This is why red-haired people almost universally have fair skin and often have freckles, why these traits tend to run together in families, and why you almost never see a red-haired person with dark skin or minimal freckling, because the underlying genetics simply don't work that way. Red-haired people also show elevated sensitivity to certain anesthetics and pain medications, a finding documented in multiple anesthesiology studies that has led some researchers to propose a direct link between MC1R variants and pain perception, though the exact mechanism remains under active research. Some studies have suggested that red-haired individuals may have higher pain sensitivity, generally, though this finding remains contested and far from conclusive in the literature. What's clear is that MC1R, the gene responsible for red hair, appears to have effects extending beyond just pigmentation and into pain processing through mechanisms that scientists are still working to fully understand, a reminder of how single genes often have multiple, sometimes unexpected effects across the body, a phenomenon called pleiotropy that we've encountered multiple times across traits covered on this channel. Think about everything actually written into a red hair follicle. A specific mutation in a specific place on the MC1R gene, present in 2 copies, inherited from 2 parents who themselves inherited it from their own parents, stretching back through generations. A mutation that meant something for survival in specific high-latitude, low-sunlight environments, beneficial enough that it reached notable frequencies in populations settling into those regions. A trait so visually distinctive that it attracted cultural attention and mythology across entire civilizations, sometimes celebrated, sometimes persecuted, but never quite suppressed into extinction. A genetic marker so specific that it almost acts as a direct pointer back to specific ancestral populations, to Yamnaya-descended migrations, to ancient Celtic and Norse populations settling into northern and western Europe thousands of years ago. Modern DNA testing has made this entire story verifiable and documentable in ways that would have been impossible even 20 years ago. Autosomal testing today can identify your specific MC1R variants directly, flag whether you're a carrier for red hair even if your own hair isn't red, and give you a genuinely evidence-based picture of which ancestral populations most likely handed you that specific genetic combination, whether your family history says Scotland, Ireland, Scandinavia, or some completely unexpected region nobody in your family ever mentioned in connection with red hair. That same visibility also made red hair a genuine target for systematic bias and suppression that persisted for centuries in ways that are uncomfortable to fully acknowledge. Beyond the witch trial context, historical records from medieval monasteries and other religious institutions occasionally document efforts to suppress red hair or treat it as a mark requiring correction, though most such efforts were limited to social pressure rather than legal action. More pervasively, red hair carried enough negative cultural association that red-haired people throughout history reported experiencing prejudice, mockery, and social exclusion in communities where red hair was rare enough to be genuinely unusual. That social pressure, while relentless, ultimately proved ineffective at suppressing the trait genetically because social bias and cultural discrimination cannot change the underlying DNA that parents pass to their children, no matter how strong the social pressure becomes. What's genuinely fascinating is that red hair, despite its historical baggage of persecution, suspicion, and prejudice across multiple centuries and multiple cultures, has never been selected out of the human gene pool. Red-haired people have survived witch trials, survived migration into regions where their fair skin and sun sensitivity were genuine liabilities, survived all the historical and cultural forces that theoretically should have suppressed the trait. And they've survived because the MC1R variants producing red hair are genuinely tied to adaptation for low sunlight environments, meaning populations in Northern Europe continue to benefit from carrying them. And because once a genetic trait reaches a meaningful frequency in a population, it's genuinely difficult to eliminate through anything short of active, intentional suppression at the genetic level, something far beyond what cultural pressure alone could ever achieve. The trait has persisted simply because it's adaptively useful in the environments where it reached high frequency, because it's not so disadvantageous as to be weeded out by natural selection, and because the same visibility that made red hair a cultural target also made it impossible to ignore or erase. So the next time somebody tells you that red hair just appeared out of nowhere in your family, you'll know exactly how deep this actually runs, all the way back through specific MC1R variants, to specific ancient populations, to specific survival pressures in specific environments thousands of years ago. Red hair isn't random. It isn't noise in the genetic system. It is a direct, traceable connection to ancestors who lived in low sunlight regions, who benefited from mutations reducing their overall pigmentation, and who passed those mutations forward through hundreds of generations, all the way down to you, carrying that same rare, distinctive, visually striking marker on your head every single day of your life. Your red hair was never an accident. It is a message encoded in your DNA, connecting you directly to one of the most specific, most rare, most geographically concentrated genetic stories in all of human biology, and now, finally, you know exactly what that story is. There's one more layer to this story worth exploring because it connects to how red hair is treated in the modern world, and it's genuinely interesting to see how science, culture, and personal identity interact around this trait. In recent decades, red hair has undergone a dramatic cultural rehabilitation, particularly in internet communities and social media spaces where red-haired people have built genuine communities around their shared trait. From Instagram, accounts celebrating red hair beauty, to social media, movements reclaiming red hair from historical stigma, there's been a genuine shift in how red hair is discussed and celebrated in modern culture. This modern reclamation of red hair as something to be proud of, rather than something to hide or correct, represents a complete inversion of the historical trajectory we discussed earlier, where red hair was treated with suspicion, fear, and active suppression across multiple centuries. That shift didn't happen because the gene changed, didn't happen because red hair became more common, didn't happen because of any biological change at all. It happened because culture shifted, because media representation changed, because people started telling different stories about what red hair means. That cultural shift is important because it reminds us that none of the meaning we attach to any visible trait is actually written into the DNA itself. The genes controlling red hair, the MC1R variants inherited from Yamnaya descended populations thousands of years ago, they don't carry any information about beauty, about morality, about character, about anything beyond the specific instruction to produce pheomelanin pigment instead of eumelanin. Everything else, all the meaning, all the interpretation, all the cultural associations, both positive and negative, that's something humans have added on top of the biology, and that something can change, has changed, and will continue changing regardless of whether the underlying genetics shift at all. Modern genetics has also opened up new possibilities for people interested in understanding their own red hair specifically. DNA testing can now identify your specific MC1R variants, flag whether you're a carrier for red hair, even if your own hair isn't red, and give you a genuinely evidence-based picture of which ancestral populations most likely handed you that specific genetic combination, whether your family history explicitly mentions red hair or not. Some people discover through DNA testing that they carry red hair variants they never expressed, variants that might show up in future generations, or variants that explain unexpected red hair appearing in their family tree. That information connects people directly to their genetic history in a way that was impossible just a few decades ago. Comment below and tell me where your red hair comes from. And tell me if it runs strongly in your family or if you're the only redhead in your bloodline. Because family patterns around red hair are exactly the kind of real-world data that helps geneticists understand which populations carried these variants most prominently. Subscribe, because next time we're revealing another DNA story hiding in plain sight on your body. And this one is just as surprising as this.